All right, this next video is going to cover reflections and reflections only. So, if you have your notes from class, we're going to start with example 3. And we're going to be reflecting over the x-axis. So if you remember our original example with our letters, okay, this is the x-axis, and we're going to treat this as the mirror line. So this is the mirror that our shape will look into and see its reflection on the other side. Now, we're going to use a quadrilateral this time instead of a triangle. So we're going to use quadrilateral ABC. A is going to be at -2, 3. So let's go ahead and plot that. So we'll go -2, so that's left 2, and then 3, up 3. So here's A. Let's do that in red. Keep our pre-images all the same color. So here's A. B will be at 0, 5. So we won't go left or right any, but we will go up, let's see, 3, 4, 5. Okay, so there's point B. C will be at 3, 1. So that's this point right here. And then D will be at 3, 3. Now, technically, you want to have your points named in alphabetical order all the way around. Sorry, just not going to happen here. So, let's go ahead and play connect the dots. Let's see. Get this drawn in. Do a better job than that, or not. There we go. And there's our quadrilateral. All right. So we're going to reflect this over the x-axis. So what we need to do is we're going to treat the x-axis as if it were a mirror. Think about any time you've ever looked at yourself in the mirror. If you look at yourself in the mirror and you are very, very close to the mirror, then your reflection will appear very, very close to the mirror. If you stand further away from the mirror, your reflection appears to be further away. So what we're going to do is we're going to treat each of these points like a person. So let's start with A here. If A looks down into the mirror, and again, the x-axis is going to be our mirror line. If we look down, A is 3 units away. Let's count them. 1, 2, 3. So that means on the other side of the mirror, 1, 2, 3 spots out is where A's reflection will appear. So that's A prime. All right? So let's write those coordinates in. So that's at -2, -3. So let's write that in. -2, -3. All right. Let's take a look at B. If B looked into the mirror, notice B is really far away. So 1, 2, 3, 4, 5 units away from the mirror. So B's reflection is going to appear 5 units away. 1, 2, 3, 4, 5. Okay. So there's B prime. Okay. So B is at 0, or excuse me, B prime rather, is at 0. -5. All right, let's look at C. C is really close, only 1 unit away. So C prime is only going to be just down 1 unit. Okay, so this is at 3, -1. And then let's look at D. D is about the same distance A was, 3 units out, so let's count. 1, 2, 3 units out. There's D prime. So this is at 3, -3. Let's connect the dots. Let's make some observations. Okay? Once again, we've got a rigid transformation. Okay? Notice our pre-image and our image look exactly the same. The only difference is that our image is the mirror image of our original. Okay? Everything else is exactly the same. So this is a rigid transformation. Okay? But let's look at something else. Let's look at our coordinates. For A, we were at -2, 3. For A prime, we're at -2, -3. Okay? For B, 0, 5. B prime, 0, -5. Okay? What's happening? Well, how could we write this out in coordinate notation? Well, let's look at all of our x's. How are the x coordinates changing? So let's see, we had -2, 0, 3, and 3. -2, 0, 3, and 3. Well, it looks like the x's didn't change at all. Well, let's look at the y's, see how they changed. 3, 5, 1, and 3. -3, -5, 1, or excuse me, -1 and -3. They're opposites. These are all positive. These are all negative. So we'll write this in as the opposite of y. Now, at first you might think, what do you mean the opposite of y? That looks like negative y to me. Well, here's the deal. We don't want to view this as being negative. Okay? We want to view it as an opposite. Because, for example, what if this was the pre-image and I wanted to reflect it? Well, notice, this lower c is at -1. If I reflect it, okay, its image would be a positive, okay, the opposite. So when we see things like this in our coordinate notation, we're not going to think negative y. We're going to think the opposite of y. So instead of +3, I'll think of its opposite, -3. Instead of +5, we'll think of -5. So this is our coordinate notation. So once again, I didn't have to sit here and count from the mirror line every single time. Okay, you don't have to do that. Instead, what you can do is say, well, if I'm going to reflect over the x-axis, all of my x-coordinates stay the same. So I could have copied down this -2, this 0, and our 3's right off the bat. Then gone back and said, well, now I need the opposite of all my y's. Because notice, the y's are what changed. So instead of +3, I'd write -3. Instead of +5, I'd write -5, and so on. So that way I can get my final coordinates. All right? Let's try another reflection, but this time, let's go over the y-axis. All right? So I'm going to switch out colors here. And what do you know? We're going to keep that same shape again, just for the sake of argument and keeping things easy. So A is at -2, 3. So A stays the same. B is at 0, 5. So we'll keep that the same. C is at 3, 1. Keep that the same. And then D is at 3, 3. Keep that the same. Drawing our sides. Now, this is going to be different. Instead of using the x-axis, we're going to use the y-axis. So this is now my mirror line. Okay? So let's get our new points, and we'll still use that counting method just again to show you how it works. So let's look at A. A is pretty close to the mirror line. It's 1, 2 units out. So I'm going to count 1, 2 units over, and that'll be its reflection at A prime. So A is now at 2, 3. So A prime at 2, 3. All right? Well, let's look at B. B is sort of an interesting case. B is right on the mirror line, which means I would have to move 0 units to be back on the mirror line. So B and B prime happen to be the exact same point. So we'll go ahead and copy that point down. 0, 5. All right, well, let's look at C and see where it ends up. C is 3 units out, 1, 2, 3. So let's count 3 units over. 1, 2, 3. There's C prime. All right, so that's at -3, +1. All right, and let's look at D. D also happens to be 3 units out, so let's count over. 1, 2, 3. So there's D's new spot at D prime. So I would have gone over -3 and up +3. So -3, +3. All right, well, let's draw it in. So D to C, C to A to B, and so on. Now, it is perfectly okay that our image and our pre-image all kind of intermingle here. It happens. Kind of makes it look a little bit more interesting, though for some people it may look a little more confusing. But let's make some observations. First, it is a rigid transformation, meaning that, hey, our two images here, our pre-image and our image, are the same. They're congruent. Let's look at our coordinates and see if we can figure out our coordinate notation. Instead of having to do all this crazy counting, was there a rule in place, our coordinate notation here, to help us get there a little bit quicker? Well, let's look. Figure out our x's first. I had -2, it's +2. 0, 0. That didn't tell me much. 3, -3, 3, -3. You know, it kind of looks like the opposite. I started with -2, now I'm at +2. We're at +3, now at -3. So looks like I found the opposite of x. Now remember, the opposite of 0 is 0. Okay, so that one didn't help us much. But we do find the opposite of x. So let's look at y's. How did they change? Well, started with 3, 5, 1, and 3. 3, 5, 1, and 3. Looks like y's didn't change. Well, this ought to be a little bit easy to help us remember. If y is going to be our mirror line, then the y remains unchanged. It's the x that needs to do the changing. let's look back. If it's the x-axis that's our mirror line, notice the x remained the same. It was the y's that changed. So if I'm going to reflect over the x-axis, I'm going to have to change my y's out. Or if I'm going to reflect over the y-axis, then hey, my x's are the ones that need to change. So take a look. If I have negative 2, 3, the y stays the same, so we'll keep that 3. But x has to be its opposite. Again, not negative, opposite. So the opposite of negative 2 is positive 2. Or the opposite of positive 3 is negative 3. And think of it in those terms. So that takes care of reflections. Our next video will cover the ever-feared rotation. We'll cover it, no big deal.